Okay, guys, today is April 7th, 2020. Be coming at you with a video here. We got quite a bit of stuff to go over today, so I'm just going to kind of jump into it. I'm going to try not to go into my typical side rants that I sometimes get into. But so what we're going to do is we're going to go over the CME that happened yesterday, and I got some more stuff to add to that. I'll be able to show you the whole thing because the data is updated and we're able to look at it. Also, I'm getting a lot of questions about Comet Atlas, and I'd already touched on it before, just kind of giving you a basic overview of what it actually is, not where it's heading, this, that, and all that stuff. I haven't talked about that yet. There's a lot of people talking about it, and there's people on both ends of the spectrum. Okay, there's people that saying, "Man, this ain't nothing. Don't even look at it." And then you got people over here saying it's the end of the world. So, I mean, where are you going to fall? I guess I'm just going to show you some of the information, and you can draw your own conclusion. That's where I'm going to leave it. I'm not going to, I don't want to influence somebody in that way. You guys are smart, so I'm just going to show you the observations, and no harm, no foul. Believe how you want to believe. So, also, there's some crazy stuff going on with the magnetosphere. I'm going to give you a Schumann update also. So, stick around for that. Okay, guys, here's that CME that I was showing you guys yesterday. Okay, we get all the data's in, so we're able to look at it. Okay, now this is about how big it got, obviously, and we'll walk through it here. Okay, so you see what it's doing. I mean, it's typical CME type of stuff. Okay, now Scott took those captures right there, and even before that, and did use his programs and stuff on it, and was able to draw out some stuff that was there. And so I'm going to send you guys. I'll send you guys over there to take a look at that. He did a good job on it. So and you guys will want to see him. It's pretty cool. Excuse me. Sorry about that. Now you remember me also saying that a lot of times when we see a CME about 180 degrees on the other side, there's one usually smaller than the one that happened first. Okay. Usually we see that within a few hours, or sometimes even like right after, but also sometimes within 12 to 24 hours. Now, I'm not saying that there's any science behind that. I don't know. I've really never heard anybody even talk about that but me. It's just something that I observed, through the past couple years. You guys can go look at it yourself. I mean, just go look at some CMEs on these tools, and then look on the other side about right after, up to a day later, and most of the time you're going to see another CME off the other side that's smaller. I don't know if there's any true reason for that. About 75% of the time that happens. So, take that for what it's worth. Whether or not that's in the books or if it whatever, I don't know. It's just something I observed. So, but as you can see, obviously we had this. Okay, now I'm going to take you, let's just do it this way. We'll back it up. I hate this thing sometimes, man. Sometimes it's hard to toggle through this stuff. Come on. Almost. Okay, now you see that, right? That's the same day, just at the end. Okay, that's the CME. It's about 12 hours afterwards. Okay, now we can back this up some more. And you're going to see that it's going to pick something up, but it moves through real fast. Okay, see that? Now watch. It picks something up right there. That's what this tool is designed to do. It's designed to see the leading edge, and plus it outlines it. Okay, that's what it's trying to do. So it noticed something there. And then it pops out oops, I hit the next day. That was stupid. Anyway, what it does is about 2 frames, it pops on through, right? So, you can see here that it's still, some of that energy is still coming off. Look at that, okay? Now it ain't the typical ball-looking shape that we usually see, or, the big puff of explosion like half halo stuff, okay? But that's definitely energy coming off of the sun. You can tell that by just going over here and seeing how bright that is. Plus, if you look at it, you can see how it's starting to spread out. So it does look like there's going to be something popping off here. Okay, it already did. Now, again, I can't say that it's coming at us. I don't know. And if you look real close, you're going to see some jets here off the top, kind of moving from right to left. Again, we can't say if that's coming from the this side of it or the back side of the sun. We just simply don't know. We can't see it because the occulter's there. So there's those little CMEs right there. I just wanted to give you guys an update on that. Okay, here's the Schumann. I'll give you an update on this. Now, like I said, guys, I was trying to wait and see if this was going to be, if this event was going to keep on lasting, and it looked like it stopped about 24 hours. Okay, if you look over here when this one started, roughly right here, and then if you obviously if you go over here to the 8, that's about when it stopped. Okay, it may have went on a little bit longer. Kind of looks like it might have went past a little bit 24 hours. But the fact of the matter is, we had some activity right there. I mean, look at that. That's quite a bit of activity, guys. But it does look like it faded off. Doesn't look like it's there now. This was kind of an odd looking signature here. I haven't seen that one very often. I think I've seen it a couple times before. But it's there. It's doing it now. That's right about what hertz level was at. Yeah, that's our base. Okay, not our base frequency, but that's our normal frequency. And for whatever reason, it was pretty intense right there. Also, guys, look, the dash line's still there. Also, we got the stripes still there. Now we got this coming back. You see these curved? Again, think about what that means with those curves. Okay? You got to always keep in mind that there's multiple stations that this thing takes its readings from, and it takes an average of all those stations and puts it into this model. So for that to show a curve like that, it means that's crazy, to be honest with you. To think of all the stuff that had to come together to make that happen. It's just really odd. I don't know. Obviously, if you just look at it, verbatim on the surface there, all you're basically saying is it's spiking up at a slow rate. Okay, but again, you have to understand there's multiple stations reporting different numbers in, or different intensities and stuff, and they take the average. So for it to actually look like that is, in my opinion, it's kind of rare. I've seen them before, but I've seen quite a bit of stuff on this tool, and but still, I still want to emphasize that these spikes are what really we need to pay attention to. Okay, that's what's most important about this, because most certainly this is what's affecting us the most. All right, now I will say this too. For people that watch this, they already know all this. Okay, but a lot of times when we get spikes like this, sometimes it affects people differently. If you're more sensitive to this, it could have a negative effect on you, or it could actually have a positive effect on you. But what I'm saying is, when these spikes are happening, usually there's no middle ground. Okay, either you're really, really high up, or you're really, really low. There's not usually typical any kind of thing in the middle when these spikes are happening. So that's something that I've noticed myself. People sometimes Scott said he was, just on fire. His brain just wouldn't quit moving. And then I talked to other people like, man, I really feel bad today. My ears are ringing really bad and all this other kind of stuff, right? So there's both ends of the spectrum there. Okay? And this was all happening during all this. So, so when we get here, where there's really not a whole lot going on, that's when we kind of find our peaceful state usually. I would think. That's just my opinion. So yeah. So we'll leave it at that. But I did want to show you guys that, give you an update on that it did, it finally stopped, but it was about 24 hours or a little bit more. And we always look at these things because sometimes we have to keep in consideration that, there's particle colliders here on Earth. And there's not just CERN, guys. There's multiple high-speed particle colliders. Okay? So they can. We don't always have to just say, "Hey, CERN caused this," or "It did this, it did that." Yes, it's a really powerful particle collider, and yes, we need to pay attention to it. But there's other ones across the planet. So when those things are firing too, we got to pay attention, because anytime those things get fired up, man, I mean it does. It'll change the vibration really, really quick. So, I mean, a lot of people have noticed it before. I've noticed it myself, as far as looking at this tool when those things are active. Of course, they're not going to tell you exactly when that thing's moving or even what it does. And there's a whole lot of theories on what those things can actually do and accomplish. And, I tend to think that a lot of those theories are really actually the truth. So, when we're not going to get into that in this video, but I just wanted to show you guys that. Okay, guys, just real quick here, I want to show you what's going on with the magnetosphere too. Okay, now obviously you guys are seeing some red there, right? That's a pretty good energy going on there. But that's not really what I want to talk about. Okay, what I want you guys to understand is first is that we're looking at a two-dimensional model. Okay, and it's trying to represent something that's three-dimensional. So it's kind of hard to understand or visualize what this thing's actually showing you. Okay, this isn't a two-dimensional video game. We don't live in that world. We live in a three-dimensional world. But this is what they've given us to look at, and I don't expect three-dimensional models. That's not what I'm saying. I just want to make sure that everybody understands that. And the way you can look at our magnetic field that's around us, surrounds us, our magnetopause and magnetosphere, all that stuff. This is how you can look at it. It's like a bubble, all right? But it's only like a half of a bubble that kind of arcs, that kind of bends around us. So what I'm saying is, you can kind of picture it like this. Remember when you were a kid, you got your big old tub or bottle of bubbles, soap bubbles. Take the wand, you stick it down in there, you pull it out, and you start blowing on the little end of the wand, and a bubble comes out, right? It makes a bubble. Well, that moment right before that bubble comes off of that thing, and sometimes you can even stop it there and it'll sit there, right? That's really kind of what our magnetosphere looks like around the Earth. Okay? What I'm saying is you have to understand that it's all around us. It's not like a wall, a flat wall out in front of us that's bent around. It surrounds us like a bubble. Okay? Now on the poles of the Earth, okay, it's more like a donut, I guess, because it comes in, energy can come in easier at the North and South Pole. All right? That's why. But it's more like a bubble than it is a flat arced wall in front of us. Okay? So why I'm saying that is because you can get energy, this energy right here we're looking at, could be coming over the top, could be going from underneath, could be coming around the sides. Okay? Now, around the sides, we got a way to be able to tell if that's actually kind of what's going on, because our bow shock kind of pushes it away. All right? But when we see this stuff, sometimes it can go over top of us. All right? So when we see that stuff right behind the Earth, that might be what we're looking at. It's stuff either going atop of us or below us, and then it shoots on out. It doesn't necessarily have to start in the front, get inside our bow shock, and then circle back. Okay? It could actually just be coming this way and keep going straight, but it's actually arcing up over us. And this is just what this model shows us. Okay? So I want you guys to understand that. Now, watch this. Okay, let me back that up just a little bit. Okay, now look in the back there. See that red? Watch what it does. See, I kind of opened up like a door. And it closed back up. Now I went backwards there. Okay. Frontwards. Backwards. Okay. I just want you guys to see that because that's strange. I think I've seen that a couple times before. It doesn't mean that anything really bad's going on. And what I'm going to say here, guys, is that our geomagnetic activity is not increasing right now. Matter of fact, it's low. So either there's some misrepresentation when these models and stuff, or it could be that our shields are doing what they're supposed to be doing, and that's deflecting all that energy away. So when that's why our geomagnetic activity won't go up, because the Earth's shields is doing its job. When the Earth's shields get overrun, that's when our geomagnetic activity level goes up. Okay? And we see that a lot when we get higher solar wind and, CMEs and solar flares, stuff like that. So, but I'm going to show you this too. Okay, the blue lines, guys, on this model here are the interplanetary magnetic field lines. It's our connection to the sun and to other celestial objects out there. They, in a perfect world, they really shouldn't be broken. They should be kind of like this, all the way down through this model. Now again, that's a perfect world. That hardly ever is like that, and hardly ever was. We're always getting some sort of solar wind all the time. Even though it might not be high, it could still, the density, they're finding more and more that a lot of the hits that we take, usually the density is kind of the main culprit there. That isn't so much the speed. Now, the speed does matter, but usually the density, in my mind, is, and they're actually writing papers and stuff now kind of saying that now. So, but anyway, you got this right here. Now, I personally have never seen an IMF line circle up around like that out in front of us. That's in front of our bow shock. I've never seen that. And I ain't saying it ain't never happened, because I've not looked at every capture this thing has done. Okay? I just wanted to point that out, because that's something that is strange to me. That can be a whole lot of different things. There's a whole lot of different theories on what's actually going on here, guys. Magnetically, everybody's very, very opinionated on this, and everybody doesn't want to come off of what they think it is either. Okay? And, sometimes that causes a lot of tension. And when all that tension and stuff is there, we don't find answers. I'm just saying, okay? So I'll just leave it at that. Now, see that's piling up out there? Okay, so I mean, that's kind of strange stuff. Now, we see this happening behind us before, okay? There's a whole lot of reasons why that could be happening too. And then again, everybody has their own ideas on what's going on there. I'm just showing you guys the observation. You guys can make up your own mind, because there's so many things that could be. And I have to say this too. This tool was not designed to see stuff behind us. Okay? This here is to give us, an idea of what the solar wind and what our magnetics are doing out in front of us and directly right behind, right around us right here. So, I often wonder how accurate this thing is the further back it goes. That's just what I think, but that's just me. Okay. So there you go. There's that. Okay, guys. This is over Earth sky. Okay. And this is about Atlas. Now, there's a question now, is it already, breaking up? Is it disintegrating? This article came out today. We'll take a look at it here. Mike and Cindy over at Evolutionary Energy Arts went over this too. That's why I went and looked at this, because I was watching their show. And I highly suggest you guys get over there to their channels and subscribe up to them. Evolutionary Energy Arts is their main channel. Currently, right now, they're live streaming on their backup channel, which is EE Arts. And I'll leave some links in the description. But go check them out. They're great people and put out really good information. So, but anyway, we're going to get into this here real quick. There's a question on whether this thing is disintegrating already. It got real bright for a minute, but then this last time it actually got a little bit more dim. Okay, so what they're saying is, I think it was like when they first was looking at this a few days ago, as far as the brightness goes, it was like I think it was at a 7 or a 7.6. And how they rate these things, the lower the number, the brighter it is. Okay, so now they're looking at, right now, an 8.8 to a 9.2. Okay, that's the past couple nights. So in other words, it's gotten dimmer. And there's some, you guys can go over here and read this, but they're questioning now whether or not it's going to break up or whatever's going on here. It tells you a whole lot of information about this comet itself. Now, you guys can do some simple research, and I'm going to show you guys some stuff too. I'll get more into it, but the size of this thing, and you know, I hear a lot of people talking about how long the tail is. Just if you guys just Google how long is the typical comet tail, that might give you a better idea of what we're actually looking at. I'm not going to do that in this video. I will do that in a upcoming video. I'll put that in there. But you know, I want to get the stuff together before I just go out there and start blurting it out. I just want to make sure I get it right. But just go do that, guys. I am going to show you an orbit of this thing because, yeah, I just want everybody to understand how this thing is actually orbiting our sun. And one thing you're going to notice when we get over to this orbit, Scott actually made this orbit with a program. So hold on a second. Okay, guys, this is that model Scott made. And just to give you a little bit of a, ignore that, please. Sorry. Here's the Earth. Here's Venus. Here's Mercury. Here's the Sun. Here's Comet Atlas. All right. Well, it's C2019 Y4 Atlas. Okay. Those numbers are actually important. Okay. Because there's other comets out there called Atlas also. Atlas is just the system that actually detected this thing back in December. That's why it's got that name. So the numbers out in front of it is really what is designated it different than another comet. So just so you guys know that. But what you're going to notice is it gets faster as it gets closer to the sun. And it's going to go on, it's going to come through and go on out. Now there's questions whether or not the thing's breaking up. Like I just said. Whole lot of stuff there, right? So I get a lot of questions. I'm going to play this as I'm talking. But yeah, so you're going to notice how it's coming in. And again, it's on a parabolic orbit, which means that it's more vertical than it is horizontal. Okay, you guys can see that here. See how the rest of the other planets are more horizontal? Okay. Now, you see it right there. It looked like it kind of got close to stereo B, that satellite. But yeah, guys, I mean, we see this a lot with comets. We really do. And I also want to say, you know, people are talking about the size of this thing. And you really have to make sure, if you're going to talk about this with other people, that you specify that when you say that it's 5 times bigger than Jupiter or half the size of the sun, you have to be sure you tell whoever you're talking to that it's the atmosphere of it that's that big. It's not the core of it, because that changes everything. Okay? If you're trying to say that something's 5 times as big as Jupiter, moving that fast, and you know, it would do a whole lot of different things than what just the atmosphere or something like that is going to be able to do. Also, the length of the tail. Okay, I hear a lot of people talking about this. And if you just do some simple research, and you know, I'll probably do it in a future video, but the size of the tail of this thing is not out of the ordinary. Okay, I just want to say that. Yes, it seems like, to us, it would seem like it's really, really long. But the fact of the matter is, it's pretty average. Okay? That's just what it is. You can go, all you got to do is simple Google search, average size of a comet tail. It's not that hard. So, and also when you're looking at those things, make sure you're looking at the right measurement as far as kilometers and miles. Because sometimes they'll say miles, and sometimes they'll say kilometers, and you got to convert back and forth just to try to get your mind around it. Okay, so the sun is 93 million miles away from us, roughly. Okay, and if we got a tail that's 2.5 million miles long, you know, if you think about that, it's not that big, okay, in that scale. So to put that in a little bit more perspective, the distance from the Earth to the satellites I show you guys, SDO, is about 1 million miles. So this double that distance. It's really, really not that far. Okay? I think Mercury is, what, 37 million miles from the sun? So if you look at Mercury and you look at the sun, that's 37 million miles there. So we're only looking at a tail about that long. I mean, let's see here. If Atlas is over here, we're only looking at a tail that's about that long. But the way people were putting it out there, like it's some big, huge, huge thing. Okay? And I ain't saying that we don't ever go through comet tails, because we do. That's where we get our meteor showers from, most of them. Okay? So it's not, we just really got to keep this in perspective of what's actually going on. And again, I'm not saying that nothing's going to happen, because I simply don't know. For me, the biggest thing for me is its atmosphere when it gets closest to the sun. Is it going to instigate the sun to have a CME or a solar flare or something? I don't know. I don't know if it's going to do that or not. That, for me, that's really what I'll be watching for. But, other people have other ideas and all that. And, I'm sure we'll talk about that later. But for now, I'm just, this is where I'm going to leave it, okay? Yeah, I just want to watch it. I want to see what it does. It's an interesting story at the very least. But we were all like, yes, we're going to get to see a bright comet. And now they're saying that it's actually getting dimmer. So it could be breaking up. It could be doing all kinds of different things. There also, guys, if you go read that article, you will also notice that it talks about how all over the place it can be. They're very unpredictable as far as the brightness and what they do when they get closer to the sun and stuff like that. They're really all over the board. So it's hard to predict what it's actually going to do. That's what I'm trying to say. And if it does lose some of its mass, is it going to change its orbit? Its speed? I don't know. Okay, guys? I don't know those answers. But it is something that we're going to watch it, most definitely. But we're not going to fear it, guys. Okay? Don't fear. Please. Just don't let somebody get you in that state. It's not a good place. It doesn't help anything. It really just doesn't. So that's what I would say to that. We always have people on all sides of it. We really do. We got people that says, hey, man, don't even look up at the sky at all, right? That's the wrong thing to do, right? Because it is. It's the wrong thing to do. You got to be, you got to be aware. But it's also a wrong thing to do to go out here and say the world's going to end. That's the wrong thing to do, too. Because there's absolutely no way any of us could know that. None of us could. And that's kind of what I'm saying. So, I'm going to end it there, guys. God bless. Yeshua saves. And you can drink this Kool-Aid.